Welcome viewers. In this video we'll see the Kirchhoff's law. There are two laws available, Kirchhoff's current law and Kirchhoff's voltage law. First we'll see the Kirchhoff's current law. It's called KCL, Kirchhoff's current law, KCL. The statement of Kirchhoff's current law is that in a node the sum of entering current is equal to sum of leaving current. If we consider any node, the current entering into the node is equal to current leaving to the node. And in other case, the summation of total current at a junction is equal to 0. Otherwise, the sum of the current entering and current leaving is equal to 0, right? So that can be written as sum of current entering equal to sum of current leaving. So if we consider any node, the total current will be 0. That is, while adding the current entering and while adding the current leaving, adding these both, the total current will be 0. The current entering is treated as positive, current leaving is treated as negative. By adding these two, we'll get the total current as 0, right? We'll see in the diagram so that you are able to understand. Now consider this diagram. There are 4 branches available. So R1, in branch 1, the resistor R1 is available. In branch 2, the resistor R2 available. In branch 3, resistor R3 is available. In branch 4, the resistor R4 is available. So all these branches are connected at this point. This point is called a node or junction point. Right? 4 branches are available. All are connected at this point. It's called a node. We have R1, R2, R3 and R4. 4 resistors are available. The current in the first branch is I1, second branch is I2, third branch is I3, fourth branch is I4. Now see that in branch 1 and branch 3, the currents are going towards the node. Currents are flowing towards the node. That is, current is entering the nodes, I1 and I3. The current flowing through the first branch and second branch, I1 and I3 are flowing towards the node. I see the current flowing through the branch, second branch and fourth branch, I2 and I4. So current or the current is leaving the branch. Current is going away from the branch. See the direction, current direction. I2 and I4 are going away from the node. So I1 and I3 are going towards the node, I2 and I4 going away from the node. So these two, I1 and I3 is taken as a incoming current. I1 and I3 is the incoming current. I2 and I4 is treated as a outgoing current, right? Going away from the node. So according to the Kirchhoff's current law, incoming current, sum of incoming current equal to sum of outgoing current. That is, I1 plus I3 equal to I2 plus I4. The current entering the node, the sum of current entering the node is I1 plus I3. That is equal to sum of current leaving the node, I2 and I4. So this is the statement given by the Kirchhoff's current law. The summation of current entering the node is equal to summation of current leaving the node. Now bring this I2 and I4 from right hand side to left hand side. What will happen? I1 plus I3, this minus I2, this I2 while coming this side minus I2. I4 will coming this side minus I4. That is, I1 plus I3 minus I2 minus I4 equal to 0. That is, the summation of total current at a junction is 0. So these two are incoming current, so it is treated as positive. These two are outgoing current, so it is treated as negative. So while adding all 4 current, it is equal to 0. So that is the statement given by the Kirchhoff's current law, right? So the sum of incoming current is equal to sum of outgoing current. And other statement, the sum of total current in a junction is equal to 0, right? So this is the statement given by the Kirchhoff's current law. Now we'll go to the Kirchhoff's voltage law. Now we'll see Kirchhoff's voltage law, KVL. It is also called as a KVL, Kirchhoff's voltage law. What is the statement given by the Kirchhoff's voltage law? The algebraic sum of voltage around any closed path is 0. If we consider any closed path, the voltage around the closed path is 0. So in the previous case, Kirchhoff's current law, we consider the node, junction point. In Kirchhoff's voltage law, we consider closed path, right? In order to apply KVL, what we need? Closed path is needed. In the closed path, we can apply the KVL. In the closed path, the voltage is 0. In case of Kirchhoff's current law, what we need? Node. At a node, what is the current? What is the incoming current and what is the outgoing current? That is analyzed by Kirchhoff's current law. In voltage law, we are analyzing the voltage in a closed path. In other words, in a closed path, the total EMF is equal to 0. The total EMF. The one EMF may be positive, one EMF may be negative. While adding all the EMF, the total EMF is equal to 0. That is the other. In other words, we can say that total EMF is 0. That is, we can say in a closed path, potential rise is equal to potential drop. Right? Potential rise is equal to potential drop. Otherwise, total potential is equal to 0. Now we'll see this diagram so that you are able to understand. Now consider this closed loop. In KCL, we consider one node, junction point. Here we are consider one closed path. There are three resistors are connected in series, R1, R2 and R3. That is, supply is given. These three resistors are energized by this voltage source, DC voltage source. Right? R1, R2, R3, three resistors are connected in series. That is energized by the voltage V. This I is the current flowing through the closed circuit. Because of three resistors connected in series, the same current I is flowing through all three resistors. The voltage drop across R1 is V1. The voltage drop across R2 is V2. Voltage drop across R3 is V3. Right? So we have three resistors connected in series, energized by the voltage source. The current flowing through the circuit is I, total current is I. The same current is flowing through all three resistors. V1 is the voltage drop across R1, V2 is the voltage drop across R2, V3 is the voltage drop across R3. According to the Kirchhoff's voltage law statement, what is the statement? In a closed path, the voltage around the closed path is 0. Otherwise, potential rise equal to potential drop. What is potential rise? What is potential drop? So this is the supply voltage. It's called a potential rise. The potential is given from this voltage source. This voltage source, what is given to the circuit, is dropped across R1, R2 and R3. This is called potential drop. The applied potential is potential rise. That potential is dropped across three resistors. Depends upon the value of R1, R2, R3, the voltages will be dropped. Right? If more resistor means more voltage will be dropped. So based on R1, R2 value, the voltage will be dropped. So the applied voltage potential rise is equal to potential drop across three resistors. So that is given here. E equal to E is, that is V or E, both are same. The potential applied E or V is equal to V1 plus V2 plus V3. Voltage drop across R1, voltage drop across R2 and voltage drop across R3. So this is a statement given. In a closed loop, potential rise is equal to potential drop. Now bring this V1, V2, V3 from right hand side to left hand side so that it becomes negative. E minus V1 minus V2 minus V3 equal to 0. What is this? In a closed loop, the total potential is equal to 0. So one potential is rise, other potentials are drop. So while adding these two, we'll get 0. So another statement given by the Kirchhoff's voltage law. In a closed path, the total EMF is 0. So how will you find V1? V1 is nothing but voltage across R1. So V equal to IR, the general formula. So V1 equal to I into R1 because I is common. Same current is flowing through the all resistors. So V1 can be written as I into R1. V2 can be written as I into R2. V3 can be written as I into R3. So we can write the final equation E minus I1 I R1 minus I R2 minus I R3 equal to 0. So this is the final equation. The potential across potential in a closed path is equal to 0. This positive indicate potential rise, negatives indicates potential drop. While adding these two, we'll got 0 value. So that is a statement given by the Kirchhoff's voltage law. So in this video, we discuss Kirchhoff's current law and voltage law. Kirchhoff's current law, what we need is node. We are analyzing what is the incoming current and outgoing current. Kirchhoff's voltage law is applied in a closed path. We are dealing what is the potential drop in a closed path. What is the potential rise or potential drop in a closed path. Thank you. Welcome viewers. In this video, we will see the mesh analysis. What is mesh analysis? This mesh analysis is one of the basic technique used for finding current flowing through a loop in a network. So the mesh analysis is the one method, one technique to find the current flowing through a loop. Loop means closed circuit. In a closed circuit, the network is available. In that network, there are n number of closed circuit will be there. In a closed circuit, we can able to find what is the current flowing through the closed circuit, current flowing through the loop, right? So mesh analysis is the technique to find the current flowing through a loop in a network, right? In that, there are two methods available. We can follow by equation method and matrix method. First, we'll see the equation method. By framing the equation, by using mesh analysis, we can frame the equation. Now consider this network. There are two closed paths available. The supply voltage is V. There are 4 resistors available: R1, R2, R3 and R4. This is one of the closed loop. Closed loop means it is the current flowing through the R1 and R2. This is one closed path. This is another closed path. R2, R3 and R4 is called another closed path. So we can take this is the loop 1. This circuit, this path is called a loop 1. The current flowing through the loop 1 is I1. This is considered loop 2, second loop. Current flowing through this loop is I2. So the supply voltage is available. 4 resistors are connected. Based on the diagram, we can take this is one of the closed loop or called a loop 1, first loop, containing voltage source R1 and R2. So one of the closed loop, loop 1. Another loop also available here, containing R2, R3 and R4. This loop is called loop 2. The current flowing through loop 1 is I1, current flowing through the loop 2 is I2. The current direction we can take any direction, but it is better to take the uniform direction. Both loop 1 and loop 2, the current flowing in the clockwise direction, same direction. You can take opposite direction also, but the equation will change accordingly. Here I taken the same direction for I1 and I2. Now we will apply the KVL, Kirchhoff's voltage law, to the loop 1. The explanation of KVL and KCL, Kirchhoff's voltage law and current law, is explained in the separate video. The link is available in the description box. You can see that. What is Kirchhoff's voltage law and what is Kirchhoff's current law. Now we are going to apply the Kirchhoff's voltage law to the loop 1. What is loop 1? This is loop 1. So this is the equation method. We need to frame the equation. So what is Kirchhoff's voltage law? Potential rise equal to potential drop. So this is the potential rise, voltage we are applying. So this is a potential rise. So in loop 1 we have 2 resistors, R1 and R2. So voltage will be dropped across R1 and R2. So this is called potential drop. So we applied voltage is potential rise. Voltage drop across R1 and R2 is called a potential drop. So according to KVL, Kirchhoff's voltage law, potential rise equal to potential drop. So potential rise V equal to potential drop. What is the potential drop across this? V equal to IR. So I value is I1, R value is R1. So I1 R1. The potential drop across this resistor is I1 R1. Right, because I1 is flowing through resistor R1. Then we have one more resistor. What is the potential drop across R2? So this current, this R2 is connected between loop 1 and loop 2. It's a common. It's a common resistor connected between loop 1 and loop 2. Both I1 as well as I2 also flowing through the resistor R2 because it is connected in between loop 1 and 2. See the current direction, the I1 is flowing from top to bottom. See the I2 is flowing is this direction, flowing from bottom to top. So I1 is flowing from top to bottom, I2 is flowing from bottom to top. So two currents are flowing, I1 as well as I2, but I1 is flowing top to bottom, I2 is flowing bottom to top. So I1 minus I2, I1 minus I2 is flowing through the resistor R2. Because we consider the loop 1, so first we will consider I1 minus I2. So current flowing through R2 is I1 minus I2 into R2. So this is the potential drop across R2. R2 is connected between loop 1 and 2. So both I1 and I2 is flowing. So the net current flowing through the resistor R2 is I1 minus I2 because both are flowing in opposite direction. This current is flowing this direction. This current is flowing upward direction. So potential rise V equal to potential drop I1 R1 plus potential drop across R2 I1 minus I2 into R2. Now we'll go for a simplification. V equal to I1 R1 multiply, this R2 is multiplied, so I1 R2 minus I2 R2. This I1 is available in both the term, we take outside. So V equal to I1 into R1 plus R2 minus R2 I2. So this we can take, this is the equation number 1. Right. So based on the Kirchhoff's voltage law, potential rise equal to potential drop. Potential rise is V. Potential drop across R1 is I1 R1. Potential drop across R2 is I1 minus I2 into R2 because R2 is connected between loop 1 and loop 2. So both I1 and I2 is flowing, but both the directions are opposite. I1 is flowing downwards, I2 is flowing upwards. So I1 minus I2 current is flowing through R2. So after simplification we got this equation number 1. Now we'll apply the Kirchhoff's voltage law at loop 2, second loop. In second loop, what are the elements available? R2, R3 and R4. The voltage source is not available here. Only the drops, potential drop. Potential rise is not available. So that it is equal to 0. Right? These are all potential drop equal to 0. So what are the potential drop? First we will take R2. Same thing. R2 connected between loop 1 and 2. So both the currents are flowing. So I1 minus I2 in the first case we are taken. But in the second case, while considering loop 2, we have to take I2 minus I1 because we are considering loop 2. Right? The reference is the loop 2. So I2 minus I1. While considering loop 1, I1 minus I2. Because he consider loop 2 means loop 2 current I2 minus loop 1 current. Then potential drop across R3 is this I2 is flowing through R3. So I2 into R3. The potential drop across R4 is this I2 is flowing. Only I2 is flowing through R4. So R4 I2 that is equal to 0. The applied potential is 0. Right. So this is the potential drop across R2. Two currents are flowing. So potential drop across R3 only I2 is flowing. Potential drop across R4 only I2 is flowing. In R2 both the currents are flowing, and R3 only I2 is flowing. R4 only I2 is flowing. Now we'll go for the simplification. R2 I2 multiply R2 inside. R2 I2 minus R2 I1 plus R3 I2 plus R4 I2 equal to 0. Right. So this term I1 is available minus I1 R2. All other remaining term I2 is common. We take I2 outside. So R2 plus R3 plus R4 equal to 0. So this term related to I1, this term related to I2. You take this equation number 2. Now we have two equations, equation 1 and 2. We need two currents, I1 and I2. Two parameters we need to find. So two equations are available. By solving this equation 1 and 2, we can easily able to find the current value I1 and I2. Suppose if three currents are available, we need to frame three equations. In that automatically there are three loops available. So we need to frame three equations so that we can find three currents. In this problem, only two loops available, two currents are there. So we framed two equations. By solving these two equations, we can able to find the value of I1 and I2. Now the same problem we will see with matrix method. How to frame the matrix for the same problem. Now we'll see this matrix method. The same problem is available. The two loops R1, R2, R3, R4. This loop 1, this is loop 2. Current is in the loop 1 is I1, current in the loop 2 is I2. The voltage applied is V. So this is the potential rise. These R1, R2, R3, R4 are potential drop. Same thing we discuss equation method. Now we'll see the matrix method. In matrix method, the current assigned should be a uniform direction. You should not assign in the opposite direction. Some procedure is followed while forming the matrix. So the current direction should be uniform in all the loop. Here two loops available. So both the loop the current is flowing in clockwise direction. You cannot take one current is clock, another current in anti-clockwise. Both the currents should be clockwise. But in equation method, you can take either clockwise or anti-clockwise. Automatically the equation will change. The polarity in the equation will change. But in matrix method, we are following some procedure. So current direction should be uniform. Now we'll frame the matrix. What is the matrix we are forming? V equal to IR. This is the voltage matrix. How many voltages available? This V1. The loop 1, loop 2. Then current matrix. How many currents available? Two current, I1, I2. Then resistor matrix. So this is a format. V equal to IR. First we will see what is the R matrix. 2 cross 2 matrix. The two loops available. So 2 cross 2 matrix. If three loops are available means 3 cross matrix. 3 cross 3 matrix will be there. What is the resistor matrix? R11, R12, R21, R22. Other than diagonal, other elements are negative. If 3 cross 3 matrix means R11, R12, R13, like that 3 cross 3 matrix will be there. So this is the diagonal. Other than diagonal, it should be negative. So this is not negative, it's a positive only. So diagonal is positive, other than diagonal negative. That's why we need to take the current direction as uniform. If current direction is uniform, automatically this law will be applied. Then what is R11? R11 means the resistor available in the first loop. What are the resistor available in the first loop? This is the first loop. R1 and R2. This is loop 1. What are the resistor available in loop 1? R1 and R2. So it is R1 plus R2. R11 is nothing but resistor, sum of resistors available in loop 1. So in the loop 1, the two resistors available. So R1 plus R2. What is R12? 12 means the resistor available, commonly available between loop 1 and loop 2. That's why it is 12. 11 means only first loop. R12 means the common resistor available between loop 1 and loop 2. What is the common resistor available between this loop 1 and loop 2? This R2. This R2 is connected between loop 1 and loop 2. R2 is available in loop 1 as well as loop 2. So this R2 is the common resistor between loop 1 and 2. So it is minus R2. Other than diagonal, we need to put negative. So minus R2. Then what is R21? The common resistor available between 2 and 1. Second loop to first loop. Second loop to first loop. That also same. So R2 only. This R2 is connected between loop 1 and 2 or loop 2 to 1. So this R2 is the common resistor between 1 and 2 or 2 and 1. Then what is R22? R22 is the 2 means the total resistor available in the second loop. So this is the second loop. This is nothing but second loop. What are the resistor available in the second loop? R2, R3, R4. Right? So R22 means total resistor available in the second loop. The total resistor available in the second loop is R2 plus R3 plus R4. So R2, R3, R4. Right? So it is very easy to frame the matrix. R11 means total resistor available in loop 1. R22 means total resistor available in loop 2. R12 or R21 means the resistor available commonly available between loop 1 and 2. So we can frame the resistance matrix. What is current matrix? Only two currents available, I1 and I2. What is voltage matrix? V1. V1 is the voltage in the first loop, V. V2 is the voltage available in the second loop, voltage rise. But in the second loop, the voltage source is not available, so it is 0. If voltage source is available, we can put. Otherwise, in this diagram, the voltage source is not available, so it is 0. Now we framed the matrix, voltage matrix, current matrix, and this resistance matrix, current matrix, and voltage matrix is available. From that, how will you find this current I1 and I2? For that, a separate formula is available. So this is the matrix we framed. So this is called a del. We take it as del. This value is del. This resistor matrix is taken as del, given by the symbol del. In this resistance matrix, the first row is replaced by this voltage. Then it is called delta 1. The first row of the del matrix is replaced by voltage matrix. Then it is called del 1. Suppose the second column is replaced by voltage matrix. That's called del 2. If it is 3 cross 3 matrix, means third column will be replaced. Here only 2 columns available. So the first column is replaced by voltage matrix. Second column as it is. Here first column as it is. First column is given as it is. The second column is replaced by voltage matrix. Then it is delta 2. So the resistance matrix as it is taken as delta. By replacing the first column with voltage source, voltage matrix is delta 1. Replacing the second column with voltage matrix is called delta 2. So we can find the del value, del 1 and del 2. After finding this value, we can find I1 and I2. What is I1? Del 1 divided by del. The value of del 1, this is a determinant. We need to find the determinant value. So del 1 by del will give the I1 value. Del 2 by del will give the I2 value. Right? So it is compared to equation method, this matrix method is easy. We can easily frame this matrix. We can easily calculate the del value, del 1 and del 2. From that we can easily find the value of I1 and I2. But in equation method, according to the direction, automatically the equation negative or positive will automatically change. But in matrix method, we need to frame the uniform current direction. Then only we can apply the law. Other than diagonal, other elements are negative. That is applicable only when the current direction in all the loops are same direction. So in this video, we discuss about the mesh analysis, that is in a closed loop, how to find the current. There are two methods, equation method and matrix method. We saw how to frame the equation, how to frame the matrix. The example problem for this mesh analysis is available in the next video. The link is available in the description box. You can see that. For the example of this mesh analysis, the problems, both matrix method and equation method is available. Thank you. Welcome viewers. In this video, we'll see the problem based on the mesh analysis in equation method. The mesh analysis explanation available in previous video. The link is available in the description box. You can see that. In this video, we are seeing the problem based on the mesh analysis using equation method. The question is find the loop current for the circuit given below. We need to find the loop current for this circuit. Now consider this circuit diagram, circuit network. The 10 voltage is applied this side and other side 25 voltage is applied. There are 5 resistors available, 10 ohm, 15 ohm, 25 ohm, 5 ohm and 20 ohm. So by seeing the diagram we can able to identify this is the one closed loop. It's called a loop 1 containing 10 voltage source, 10 ohm, this 25 ohm and 5 ohm. This is called a we can consider this is the one loop called a loop 1, first loop. The current flowing through the first loop is I1. See the current direction. This is the current direction flowing in clockwise. So this is the another loop. Loop is nothing but closed path containing this 25 voltage, 15 ohm, 25 ohm and 20 ohm. We can consider this is the second loop. It's called a loop 2. The current flowing through is I2. Flowing through the second loop is I2. So the I2 also flowing in clockwise direction. So we framed 2 loops. This is loop 1 and this is loop 2. Current flowing through loop 1 is I1. Current flowing through loop 2 is I2. Both are same direction. Our aim is to find the value of this I1 and I2. So we can apply the Kirchhoff's voltage law to the loop 1. This is equation method. So we are going to frame the equation. So we will apply the Kirchhoff's voltage law to this loop 1. What is Kirchhoff's voltage law? Potential rise equal to potential drop. So this 10 voltage source is the potential rise. The potential is given from this. What is potential drop? The drop across this 10 ohm resistor, 25 ohm and 5 ohm. These are all the voltage drop. So this potential rise is equal to sum of this potential drop. That is the statement given by Kirchhoff's voltage law. So based on that we can frame the equation. Potential rise is 10 voltage, 10 equal to. So these 3 are potential drops. What is the potential drop here? V equal to I into R. What is I here? I1. I1 is flowing through 10 ohm resistor. So 10 into I1. The potential drop B equal to I into R. I is I1, R value is 10. So 10 into I1. That is the potential drop across I1. Drop across 10 ohm resistor. What about 25 ohm resistor? This 25 ohm resistor connected between loop 1 and loop 2. Commonly available between loop 1 and loop 2. So I1 current is flowing through loop 1 and I2 current also flowing through loop 2. I1 current is flowing from downwards. I2 current flowing upwards. Both are opposite direction. So while considering this 25 ohm, I1 also flowing, I2 also flowing in opposite direction. So we need to take I1 minus I2. So while considering loop 1, it is I1 minus I2. While considering loop 2, I2 minus I1. Because we considered loop 2. So I2 minus I1. Loop 1, I1 minus I2. So 25 ohm is connected between loop 1 and 2. Both I1 and I2 current is flowing. But current direction is opposite. This current is flowing downwards. This current is flowing upwards. So the difference between these two current is flowing through the 25 ohm. So we are taking I1 minus I2. 25 into I1 minus I2. Suppose the current is same. Both current is same means I1 plus I2 we can take. But here opposite. So we are taking I1 minus I2. Then what is the potential drop across 5 ohm? Only this I1 is flowing. So I1 into 5. That is 5 into I1. Right. So this is the potential rise. This is the potential drop across 10 ohm. Potential drop across 25 ohm. Potential drop across 5 ohm. So equation number 1. We will take this equation number 1. We'll simplify this equation later. First we'll take it as equation number 1. Now see the potential of this 10 volt. See that current direction, current is flowing in a clockwise direction. That is, it is flowing from downward to upward. In this 10 ohm voltage source, it is flowing downward to upward. Let's see the direction. It is flowing like this. So from negative to positive, the current is flowing from negative terminal to positive terminal. So potential rise, so that we are taken plus 10. But while considering this 25 ohm, see this, the current is flowing downwards from positive to negative. Positive terminal to negative terminal. Potential is dropped here. So minus 25. See here, this current is flowing upward, bottom to top, negative to positive. So rise of potential, 10 voltage. Here following from top to bottom, positive to negative, fall of potential. So minus 25. So flowing this downwards, positive to negative. So minus 25 volt. So this is the potential. What is the potential drop? There are 3 resistors available: 15 ohm, 25 ohm and 20 ohm. In 15 ohm only I2 is flowing. So 15 into I2. In 20 ohm also only I2 is flowing. So 20 into I2. But in 25 both I1 and I2 flowing. We already see that both are opposite. So in previous case we taken I1 minus I2. While considering loop 2 we need to take I2 minus I1. Right? So this is the potential applied. This is the potential drop across second loop. We take this equation number 2. Now we'll simplify this equation 1 and 2. Then we can go for further modification so that we can find the value of I1 and I2. Now we framed equation 1 and equation 2 from loop 1 and loop 2. Now take this equation 1. This equation 1 is taken as it is. Now we are going for simplification. So we consider the equation 1. Now we'll go for simplification. 10 equal to 10 I1. We multiply inside. 25 multiply inside. So that 25 I1 minus 25 I2 plus 5 I1. So this 25 is multiplied inside. So 10 equal to this I1 available here, 10 I1, here 25 I1 plus 5 I1. So 10 plus 25, 35 plus 5, 40 I1. This I2 available only one time, minus 25 I2. Right? So we can rewrite this. 40 I1 minus 25 I2 equal to 10. So it is rearranged. Right hand side and left hand side terms are rearranged. So that 40 I1 minus 25 I2 equal to 10. So we can divide by 5 so that the equation further simplified. So 40 divided by 5, 8, 25 divided by 5, 5, 10 divided by 5, 2. Now it is simplified form of equation 1 is available. Equation 1 is now simplified. 8 I1 minus 5 I2 minus 2. Take this equation number 3. Right? So step by step the equation is reduced and finally we got this equation, simplified equation. We take this equation number 3. Now consider the second equation. The second equation is written as it is. What is available second equation? Written as it is. Now we go for simplification. Minus 25 equal to 15 I2. Multiply this 25 inside. So 25 I2 minus 25 I1 plus 20 I2. Right? This 25 is multiplied. So minus 25 equal to, see this I2 available here. 15 I2, 25 I2, 20 I2. 3 times available. So 15 plus 25, 40. 40 plus 20, 60 I2. And I1 available one time. Minus 25 I1. I will go for further simplification. So now the terms are rearranged. Minus 25 I1 plus 60 I2 equal to minus 25. Right hand side term is brought to left side and left side term is brought to right side. So here also we can divide by 5. So 25 divided by 5, 5. 60 divided by 5, 12, minus 25 divided by 5, minus 5. You take this equation number 4, right? Now the equation 2 is simplified, and finally we got this equation, simplified equation. This takes us equation number 4. Now we got equation 3 and 4, simplified form of equation 1 and 2. So by solving these two equations, we can find the value of I1 and I2 by solving this equation 3 and 4. How to solve this? So we can cancel any one term, either I1 or I2. Here 8 I1 available, here 5 I1 is available. So we can multiply the equation 3 with 5, equation 4 with 8. So that here multiplied by 5, here multiplied 8, so that we'll get 40. So we can cancel the term I1, right? So that is available here. So equation 3 is multiplied by 5, equation 4 is multiplied by 8 in order to cancel I1. So 40 I1 minus 25 I2 equal to 10. This equation 3 is multiplied with 5. Similarly, equation 4 is multiplied by 8, minus 40 I1 plus 96 I2 minus 40. Right? The equation 4 is available here. This equation 4, that is multiplied with 8. Now see this is plus 40 I1 and minus 40 I1. So by simply adding this, automatically this term got cancelled. So this term got cancelled. We can add the terms because one is positive, one is negative. So minus 25 I2 here, 96 I2 is there. So difference between these two is 71 I2. Similarly 10 here, minus 40. So minus 30. Resultant will be minus 30. 71 I2 equal to minus 30. So I2 equal to minus 30 by 71. So by dividing this minus 30 by 71, it is minus 0.42 amperes. So I2 is minus 0.42 ampere. Right? Now we calculated the value of I2. By substituting this I2 in equation 3, we'll consider this equation 3. In this we can substitute this I2 value. So 8 I1 minus 5 I2 equal to 2, that is equation 3. In that we are going to substitute the value I2 equal to minus 0.42. Right? So while substituting, we'll see what will happen. So 8 I1 minus 5 into this I2 is minus 0.42, that is equal to 2. So 8 I1, you multiply both are negative, so it becomes positive. 5 into 0.42 is 2.1, that is equal to 2. So bring this 2.1 in right hand side. So 8 I1 equal to 2 minus 2.1. So 2 minus 2.1 is minus 0.1. This is more value, so minus negative. So from this I1 equal to minus 0.1 divided by 8. So that is nothing but minus 0.0125 amperes. So now we got the I1 value also. So I2 value is minus 0.42 ampere, I1 value is minus 0.0125 ampere. So in this problem, by using the mesh analysis, by equation method, we framed two equations, then it is simplified form of equation is given. By solving the equation 3 and 4, we got the value of I1 and I2. The same problem is solved by matrix method. That video available in the description box. You can see that video. The link is available in the description box. The same problem solved by matrix method. The link available in the description box. Thank you. Welcome viewers. In this video, we'll see the mesh analysis by solving the problem by mesh analysis using matrix method. Mesh analysis using the matrix method. So the problem is find the loop current for the circuit given below. For this circuit, we need to find the loop current using matrix method. The same problem solved by equation method. The link is available in the description box. The viewers can see by click the link, you can see the video. The same problem solved by equation method. That separate video available. The link is available in the description box. You can go through that. You can see the video. By clicking the link, you can see the video. So in this video, we'll solve the problem with matrix method. So in this circuit diagram, this 10 voltage source is available one side, 25 voltage source available on other side. There are 5 resistors available, 10 ohm, 25 ohm, 5 ohm, 15 ohm and 20 ohm. So by seeing the diagram, we can easily identify this is the loop 1. We can consider this is the loop 1. Loop is nothing but closed path. This is one closed path, loop 1. The current flowing through the closed path is I1. Loop 1 is I1. In clockwise direction. The current is flowing in clockwise direction. This is another loop. Loop 2. We can consider this is the second loop. Loop 2. That is 25 ohm, 25 voltage, 15 ohm, 25 ohm and 20 ohm. These 4 are considered as the second loop. Loop 2. The current flowing through the second loop is I2. That also flowing in a clockwise direction, right? So we have 2 loops available, loop 1 and loop 2. Current flowing through loop 1 is I1, current flowing through loop 2 is I2. Both are clockwise direction. Now we can frame the matrix. What matrix we are framing? V equal to IR. This is a voltage matrix, current matrix, resistance matrix. Because we are applying the Kirchhoff's voltage law. We are going to apply the Kirchhoff's voltage law, so that we follow the matrix V equal to I into R. What is resistance matrix? R11, R12, minus R12, minus R21 and R22. 2 currents I1, I2, 2 voltage V1 and V2. The explanation of mesh analysis is also available in separate video. Link is available in the description box. The viewers can see that. We can view the video. The link is available. So what is R11? R11 is nothing but the resistance of the first loop. The total resistance of loop 1. In loop 1, what are the resistors available? 10 ohm, 25 ohm and 5 ohm. So sum of these 3 is nothing but R11. Loop 1. R11 is nothing but sum of resistors in loop 1. So 25. So 10 plus 25 plus 5. 10 plus 25 plus 5. Sum of resistors available in the first loop. What is R12? R12 is the resistor available between loop 1 and loop 2. Which resistor is connected between loop 1 and 2? This 25 ohm. This 25 ohm is available in loop 1 as well as loop 2. Commonly available between loop 1 and 2. So R12 is nothing but the resistor commonly connected between loop 1 and loop 2. That is minus 25. R21 also same. Connected between second and first loop. Second and first loop. The same. 25 ohm is connected between second and first loop. Minus 25. Then R22. What is R22? The resistors, the sum of resistor connected in the second loop. The second loop. This is 15 ohm plus 25 ohm plus 20 ohm. 15 plus 25 plus 20. Right. So R11 is resistors available in the first loop. R22 is the resistors available in second loop. R12 or 21 means resistor available, commonly available between loop 1 and loop 2. That is nothing but this 25 ohm. Now frame the resistance matrix. What is the current? I1 and I2. That only we need to find. I1 and I2. What is the voltage? 10 voltage. In loop 1 we have 10 voltage. See the current direction. It is flowing in anti-clockwise, clockwise direction. So here it is going from down to up, from negative potential to positive potential. So potential rise. Right? See the current direction. So current is flowing like this. Here it is going upward direction. The current is flowing in a upward direction. It's flowing like this. So that it is from negative to positive. So we can take plus 10. But see here the current is flowing from up to down. That is from positive to negative. So it is a drop of potential. So we take minus 25. So this is very important, right? So see the current direction. Easily you can see the current direction. The current is downwards. Downwards mean positive potential to negative potential. Potential reduced here. So minus 25. But see the current here, it is upward from negative to positive. So rise of potential. So take 10. Right? So this is very important. Based on the current direction, we can identify whether it is rise of potential or fall of potential. Now we can simplify this matrix. So 10 plus 25 plus 5, that is 10 plus 25 35, 30 plus 5 40. So this minus 25. These diagonal matrix are always, other than diagonal, all matrix are negative. Then that is also available in the separate video, mesh analysis explanation. So 15 plus 25 40, 40 plus 20 60. I1 I2 10 minus 25. Now how will we find this I1 and I2? That is by finding the del value, del 1, del 2, right? Now this is the del value. By replacing the first column with voltage matrix, we will get del 1. By replacing the second column with voltage, we will get del 2. Now we will see this one by one so that you are able to understand. Right. So this is the resistance matrix, that is nothing but del. Now we need to find the determinant. How will you find determinant? 40 into 60 minus 25, minus 25 into minus 25. Because this 2 cross 2 matrix, the determinant is very easy. That is nothing but multiplication of these two minus multiplication of these two. Right? So this is very simple. 40 into 60 minus 25 into minus 25. So these two minus become positive, but already here one negative is there. So it is minus only. So 40 plus 60 is 2400. 25 into 25 is 625. So 2400 minus 625, 1775 is delta value. Then how will you find delta 1? You have to replace this first column with this voltage matrix. So this is replaced by voltage matrix, 10 minus 25. Second column as it is, minus 25, 60. Right? The replacing the first column with the voltage matrix will give delta 1. So 10 into 60 minus 25 into minus 25. So 10 into 60 minus 25 into minus 25. 10 into 60 is 600. So this negative, these two negative become positive, but here one negative is there, minus 25. So 600 minus 625 is minus 25. Now we got the value of del and del 1. Now we'll go to find delta 2. So the delta 2, the first column is as it is, second column replaced by the voltage matrix, 10 minus 25. Now how will you find the determinant? 40 into 25. 40 into 25 minus 10 into minus 25. The determinant is very simple. You have to multiply these two minus multiply these two. So 40 into minus 25 minus 10 into minus 25. So 40 into 25 is minus 1000 because negative is there. Here two negatives are available, so it becomes positive, plus 250. So minus 1000 plus 250 is minus 750. Now we got the delta 2 value also. So from del 1 and delta 2 we can find I1 and I2. I1 is nothing but delta 1 by delta. Minus 25 divided by 1775. That we already calculated delta 1 and del. So it is minus 0.01 amperes. 25 divided by this 1770 will give minus 0.1 minus 0.01 amperes. Similarly, I2 equal to del 2 divided by del. Minus 750 divided by 1775. That is minus 0.42 amperes. Right. So from this del value we calculated I1 and I2. So by using the matrix method, mesh analysis, we calculated the loop current I1 and I2. The same problem solved in equation method also That video link is available in the description box. The viewers can go through that video. So the mesh analysis done by both equation method as well as matrix method. Thank you. Welcome viewers. In this video we'll see the problem based on the mesh analysis by equation method containing the 3 loop. The question is find the loop current and also find the power absorbed by 8 ohm resistor. Consider this diagram. Circuit network is available. The question is we need to find the loop current I1, I2, I3 and also power absorbed by this 8 ohm resistor. So in this we have two voltage sources available, 100 voltage and 40 voltage. So this is nothing but a first loop. The current is flowing in a clockwise direction. This is a loop 2, I2, current I2 flowing in clockwise direction. This is loop 3. The current I3 is flowing in clockwise direction. The current direction taken as same current direction. Direction is same for all 3 loops. Loop 1, loop 2, loop 3. The current is I1, I2 and I3. So our aim is to find the value of current I1, I2, I3. And also one more question, what is the power absorbed by this resistor? P equal to V into I, that is this V. The I is nothing but I1. So V into I1, if you multiply, you will get the power absorbed by 8 ohm resistor. But so by using this equation method, we need to frame the 3 different equations by using the Kirchhoff's voltage law for loop 1, loop 2, loop 3. We need to frame 3 equations. By solving these 3 equations, we can find these 3 currents I1, I2, I3. There are 3 loops available. So we need to frame 3 equations. By solving the 3 equations, we are able to find these 3 loop currents. Now we'll apply the Kirchhoff's voltage law to the loop 1. What is Kirchhoff's voltage law? The potential rise equal to potential drop in a closed loop, or total potential in a closed loop is 0. So what is potential rise? This 100 voltage is a voltage source. This is a potential rise. This 8 ohm and 4 ohm available. This is potential drop. Voltage is dropped across 8 ohm and 4 ohm. So this 100 voltage is equal to voltage drop across 8 ohm and 4 ohm. So that is given by the Kirchhoff's voltage law. Potential rise equal to potential drop. Right? So based on that we can frame the equation. So potential rise 100 equal to, here this is the supply voltage, so that 100. See the current direction, it is flowing in clockwise direction. That is from, in this source it is flowing from downward to upward. That is minus to plus, negative to positive. So that 100 voltage. Voltage is rising here. See the direction. So it is going like this. It is going upward. So it is going like this. Negative to positive. So that here 100 voltage. What is the voltage drop across this 8 ohm? V equal to I into R. What is I? I1. I1 is flowing through 8 ohm. So 8 into I1 is the voltage drop. Right? So in 8 ohm only I1 is flowing. So 8 into I1 will give the potential drop. What about this 4 ohm? So in the closed loop what we have? This 100 voltage, 8 ohm and 4 ohm. This 4 ohm, what are the current flowing? See that there are 2 currents are flowing through the 4 ohm. So because it is connected common between loop 1 and loop 2. See this I1 current is flowing and also I2 current also flowing. I1 current is flowing downwards. I2 current is flowing upwards. Both are opposite direction. So we need to subtract. The difference between these 2 current will be flowing through 4 ohm resistor. So that 4 I1 minus I2. Right? So in the 4 ohm connected between loop 1 and 2, so I1 current is flowing in downward direction, I2 current is flowing in upward direction. See the direction, upward direction. Both are opposite. So difference between these 2 current will be flowing through 4 ohm resistor. So that drop is 4 into I1 minus I2. While referring loop 1, I1 minus I2. If you refer loop 2, I2 minus I1. So we frame the equation 1. Voltage rise 100 equal to voltage drop across 8 ohm resistor, voltage drop across 4 ohm resistor. Now we framed the equation 1. Now we'll consider the second loop. Loop means closed circuit. In the second loop, what are the resistors available? 10 ohm, another 10 ohm, and this 4 ohm. These three resistors are available in the second loop. First we will find the what is the current, what is the drop across this 10 ohm. Here the voltage source is not available, so it is 0. Potential rise or drop, potential rise is not available. Voltage source is not available, so it is equal to 0. What is the voltage drop across this 10 ohm resistor? This I2 is flowing through the 10 ohm. So 10 into I2 is the potential drop across 10 ohm resistor. What about this another 10 ohm resistor? This I2 is flowing in downward. This 10 ohm is connected between loop 2 and 3. So this the loop third loop current I3 also flowing in upward direction. See, the current direction is coming like this and going upward, but this current is going downward. So both the currents are opposite direction. I2 is flowing downwards, I3 is flowing upwards. So I2 minus I3, difference between these two, I2 minus I3 is flowing through the 10 ohm resistor. So the drop across 10 ohm is 10 into I2 minus I3. Then we have one more resistor, 4 ohm. We already discussed. This 4 ohm resistor, I1 is flowing downward, I2 is flowing upward. So already we discussed I1 minus I2. But while referring the second loop, we need to write I2 minus I1. While referring first loop, I1 minus I2. While referring second loop, I2 minus I1. Because we are taking 2 as a reference. Now we calculated the drop across this 10 ohm resistor and another 10 ohm resistor and this 4 ohm resistor. So this is equation number 2. We framed the second equation also. Now we'll go to the third loop. In third loop, what are the elements available? This 10 ohm resistor, this 4 ohm resistor, and one voltage source is available. So potential drop, potential rise equal to potential drop. First we'll consider this 40 voltage source. See this, how the current is flowing in the downward direction, that is from positive to negative. It is flowing like this, from positive plate to negative plate. So this is a drop in potential. So we need to take minus 40. But in case of the first source, the current is flowing from bottom to top, negative to positive, so that plus 100. But here the voltage is going downward direction, that is from plus to minus, so that there is a drop in potential. From it is going from positive to negative. Potential is dropped here, so minus 40. Then what are the resistors available? This 4 ohm and 10 ohm. In 4 ohm only I3 is flowing. So 4 into I3. In this 10 ohm, we already discussed I2 and I3 is flowing. I2 is flowing downwards, I3 is flowing upwards. Both are opposite direction. So the difference between these two current will be flowing through 10 ohm. But while referring the loop 3, we need to take I3 minus I2. While referring loop 2, I2 minus I3. That is the only difference. So this is the potential drop. It's a voltage source. This is the drop across 4 ohm and this is the drop across 10 ohm. So we framed the equation 3. That equation also framed. Right? By using the KVL for loop 1, loop 2 and loop 3, we framed the 3 equation. By solving these 3 equations, we are able to find the value of I1, I2 and I3. Before solving, we will simplify this equation. Equation 1, 2 and 3, we will simplify. After simplify, we will go for the solution. Now we will consider the first equation. So this first equation is 100 equal to 8i plus 4 into I1 minus I2. So it is written here, first equation. Now we will simplify this. 100 equal to 8i. This 4 is multiplied inside. 4i1 minus 4i2. This 4 is multiplied inside. So this 100 equal to 8i and 4i. 4i1. I1 available 2 times. 8i1 plus 4i. So this 12i1. This I2 minus 4i2. We will rewrite this. So that 12i1 minus 4i2 equal to 100. Right hand side and left hand side terms are interchanged. Now we can divide this equation by 4. So here 12, 400 is available, so that we can go for further simplification. The entire equation is divided by 4. So 12 divided by 4, 3. 4 divided by 4, 1. 100 divided by 4, 25. Right? So the equation 1 is now simplified into the form that we consider as equation number 4. 3i1 minus i2 equal to 25. Equation 1 is now simplified into form and is considered as a equation number 4. Now we'll consider this second equation. 0 equal to is available here. 0 equal to 10i2 plus 10i2 minus i3 plus 4i2 minus i1. Now we'll multiply this inside. So 0 equal to 10i2 plus 10 into i2 minus 10 into i3. Similarly 4 into i2 minus 4 into i1. This 4 is multiplied inside. Similarly here 10 is multiplied inside. So 0 equal to, so this i1 is available only one term, minus 4i1. This i2 is available here, 10i2, here one 10i2, here one 4i2. So 10 plus 10, 20 plus 4, 24i2. i3 only one term is available, minus 10i3. Now i1, i2, i3 everything are added and the equation is framed. Now rewrite this, minus 4i1 plus 24i2 plus 10i3 equal to 0. This right hand side and left hand side terms are interchanged. So here also we can divide by 2 for further simplification. 4 divided by 2, 2. This minus 4 divided by 2 is minus 2. 24 divided by 2 is 12. Minus 10 divided by 2 is minus 5. Right? Now the equation 2 is simplified. Minus 2i1 plus 12i2 minus 5i3 equal to 0. We'll take this equation number 5. Right? Now we'll consider this equation 3. We will simplify this equation 3. So equation 3 is minus 40 equal to 4i3 plus 10i3 minus i2. Now we'll go for further simplification. We can multiply this 10 inside. So minus 40 equal to 4i3 plus 10 into i3 minus 10 into i2. See, this is the i3 available, 2 terms available, 4i3 plus 10i3. So 14i3. 10i2 is available. So this equation also we can divide by 2. So for further simplification. Minus 40 divided by 2 minus 20. 14 divided by 2 7. Minus 10 divided by 2 minus 5. Now rewrite this. Multiply with negative. Right? So this minus 20 become plus 20. 7i3 become minus 7i3. Minus 5i2 become plus 5i2. Now rewrite this. So 5i2 minus 7i3 equal to 20. Right? So the equation 3 is simplified and divided by 2, multiplied by minus 1 and framed the simplified equation. We'll take this equation number 6. Now equation 1, 2, 3 is simplified and it's given the new name, new number 4, 5, 6. Right? So these equations are available here. So this is equation 4, 5 and 6. Now we need to solve these equations. By solving these 3 equations, we can be able to find I1, I2 and I3. First consider this equation 4 and 5. We will cancel this term I1. How will you cancel? See, here 3 is available, here minus 2 is available. So equation 4 is multiplied by minus 2. Multiplied by 2. Similarly, equation 5 is multiplied by 3. If we multiply in opposite side, both become 6i, so that we can easily cancel. Right? So this equation is multiplied by 2. This equation is multiplied by 3 in order to cancel I1. Right? So equation 4 multiplied by 2. What happened? 3i1 is 6i1 minus 2i2. 25 into 2, 50. Equation 5 is multiplied by 3. Minus 2 into 3, minus 6. 12 into 3, 36. 5 into 3, 15. I3 equal to 0. Right? In order to cancel the term I1, here the coefficient 3 is available, here coefficient 2 is available. So oppositely it is multiplied. This is multiplied by 2, this equation multiplied by 3, so that we are getting the same coefficient. Now one is plus and one is minus. So by simply adding these two equations, we can easily cancel this term. Right? We can add. No need to go for subtraction because one is positive, one is negative. By simply adding, this term automatically got cancelled. So sum of these two, 36 minus 2 is 34. Right? I3 is not available here. 15 I3. Now in this side also, this is 50, this is 0. So 50 plus 0, 50. So now we got, after simplification, we got 34 I2 minus 15 I3 equal to 50. Let's take this equation number 7. So here only I2 and I3 is available. I1 is cancelled. Now refer the sixth equation. Here also I2 and I3 is available. So we can cancel either I2 or I3 between these two equations. Now we'll cancel this I2. How will you cancel this? Here 5 is available, here 34 is available. So we can multiply this equation with 34. Similarly, we'll multiply this equation with 5. So that both the coefficient become equal and can cancel the I2. Now we'll go for that. So equation 6 is multiplied by 34. Equation 7 is multiplied by 5. Right? So that we got this value. See here both are 170. So we can easily cancel. But both are positive here. So we need to subtract. Then only it become cancel. The previous case one is positive, one is negative. So easily we cancel. By adding, automatically it got cancelled. But here both are positive. So we need to subtract. So we'll subtract, what will happen? One is positive, negative means cancel. So here subtract, it become plus because we need to subtract. So minus 238 plus 75, that is nothing but minus 163 I3. Here also you have to subtract. 680 minus 250 is 430. So that I3 equal to minus 430 divided by 163. So I3 equal to minus 2.64 ampere. So now we got the current value I3. Loop 3 current I3 value is calculated. By solving the equation, the first current is calculated. Now we can substitute this value in the sixth equation. Consider the sixth equation. If we substitute I3 value, automatically we can find I2 value. Right? So consider the sixth equation. 5I2 minus 7I3 equal to 20. In that we are going to substitute I3 equal to minus 2.64. So while substituting, what will happen? So 5I2 minus 7 I3 is minus 2.64, that is equal to 20. So 5I2, so both are negative. So 7 into 2.64 is plus 18.48. This minus 7, this is also minus. So become plus, that is equal to 20. So 5I2 equal to 20. Bring this term in the right hand side. So 20 minus 18.48. Here positives are, that become negative. So 20 minus 18.48 is 1.52. So 5I2 equal to 1.52. So that I2 equal to 1.52 divided by I. So 1.52 divided by I is 0.304 ampere. Now we got the second loop current I2 also. I3 already calculated. By substituting this, we got the I2 value. So by using the I2, we can be able to find the I1 current. In order to find the I1, consider the equation number 4. Here I1 and I2 is available. So by substituting I2, we can easily find I1. So substitute I2 equal to 0.304. So 3I1 minus I2 is 0.304 equal to 25. Bring this minus 3.04 in the right hand side. So that 3I1 equal to 25 plus 0.304. So by adding these two, 25.304. So 3I1 equal to 25.304. So I1 equal to 25.304 divided by 3. By simplifying, we got 8.44 amperes. So the I1 current is 8.44 ampere. Now we got all three currents, I1, I2 and I3. In that I3 is negative, I1 and I2 is positive. What is the meaning? Why we got the I3 is negative? We assume the I3 current is flowing in clockwise direction, but we got the answer as negative. It means that the current is flowing anti-clockwise direction, right? So you can take any direction, accordingly you will get either positive current or negative current. We got the negative current, that indicates the direction what we assumed is not correct. The current is flowing in opposite direction, that is anti-clockwise direction. Now one more question is there. Power absorbed by 8 ohm resistor. What is 8 ohm resistor power? Power equal to V into I. So the 8 ohm resistor connected near 100 voltage. The current flowing the 8 ohm resistor is I1, 8.44. So 844 watts. Right? Power absorbed by 8 ohm is V into I. This 8 ohm is connected nearby the voltage 100. The current flowing through this 8 ohm is I1, 8.44. So 100 into 8.44 is 844 watts. So in this problem, we consider the mesh analysis. The problem is solved by equation method by using the Kirchhoff's voltage law. The same problem solved by matrix method. That another video is available. The link is available in the description box. You can view that same problem solved by matrix method. Thank you. Welcome viewers. In this video, we will see the mesh analysis by solving the equation by using the matrix method containing the network containing the 3 loop. Mesh analysis by matrix method having the 3 loop. The question is find the loop current and also find the power absorbed by the 8 ohm resistor. Consider this network. In this network we need to find the loop current and also power absorbed by this 8 ohm resistor. So here there are two voltage sources available, 100 voltage and 40 voltage. So by inspecting this diagram we can easily identify this is the first loop. The current is I1. This is the second loop. The current is I2. This is the third loop. The current is I3. The current direction is uniformly taken. All 3 loop current is flowing in clockwise direction. By matrix method we can apply this matrix V equal to I into R. That is, we need to frame the voltage matrix, current matrix and resistance matrix. V equal to I into R based on the Ohm's law. In that the resistance matrix R11, R12, R13, R21, R22, R23, R31, R32, R33. This is a resistance matrix. What is R11? R11 is nothing but the resistance available in the loop 1. The loop 1. R22 is resistance available in second loop. R33 is resistance available in third loop. 1, 2 means available between 1 and 2. Like that we need to find. Now we'll find this value one by one. R11 is the resistance available in the first loop. What are the resistance available? This 8 ohm and 4 ohm. These two resistors are available. So 8 plus 4. R11 is the resistance available in the first loop. This is the first loop. In the first loop what we have? 8 ohm resistor and 4 ohm resistor. So 8 plus 4. What is R12? In between 1 and 2. What is the resistance commonly available between loop 1 and loop 2? So this is loop 1. This is loop 2. So this 4 ohm is connected commonly between loop 1 and loop 2. So this 4 ohm. See that by seeing the diagram we can easily identify this 4 ohm is available in loop 1 as well as loop 2. So minus 4. Other than diagonal we need to put other values are negative. It's a general procedure. Only the diagonals are positive. All other values are negative. Minus 4. What is R13? The resistance available between first loop and third loop. So there is no connection. In between first and third loop, the second loop is available. So there is no common element available between first loop and third loop. So it is 0. Right? So first loop and third loop, in between second loop is available. So automatically there is no common terminal available between first loop and third loop. Then what is R21? That is also similar. Second loop and first loop. R12 means first loop and second loop. Here second loop and first loop. Both are same. This 4 ohm is available between first and second loop. So it is minus 4. Then R22. What is R22? The total resistance available in the second loop. So this is the second loop. 4 ohm, 10 ohm, another 10 ohm. These three resistors are available in the second loop. So we need to add this 4 ohm, this 10 ohm and this 10 ohm. 4 plus 10 plus 10. R22 is the total resistance of the second loop. In second loop we have 4 ohm, this 10 ohm and another 10 ohm. 4 plus 10 plus 10. What is R23? The resistor commonly available between second loop and third loop. So this is the second loop. This is the third loop. So that this 4 ohm is available, this 10 ohm is available commonly between second loop and third loop. See that by seeing the diagram we can easily identify this 10 ohm is available in second loop as well as third loop. So it is minus 10. Then R31, third loop and first loop, we already discussed. R13 is similar to R31. So there is no common terminal between third and first loop, 0. Then R32 is similar to R23. The resistance between second and third loop. Here third and second loop both are same. So it is 10 ohm, minus 10. Then R33. What is R33? The resistance available in the third loop. What are the resistors available in the third loop? This 10 ohm and 4 ohm. These two resistors are available in the third loop. 4 ohm and 10 ohm. 4 plus 10. Right? Now framed the resistance matrix. Diagonals are positive. Other than diagonal, all elements are negative. What is current matrix? That we need to find. I1, I2, I3. I1, I2, I3. These two are unknown parameter we need to find. What is voltage? In the first loop, the voltage is 100. See the current direction. The current is flowing from down to up. That is from negative plate to positive plate. So rise in potential 100 plus 100. See the current direction. Current is flowing upward direction from bottom to up. So negative to positive. Potential is increasing. So it is plus 100. In the second loop, the voltage source is not available, 0. In the third loop, this 40 voltage is available. See the current direction 40. This I3 is flowing from top to bottom. That is positive terminal to negative terminal. So that drop in potential minus 40. Right? Here the voltage is, the current is flowing down to up, negative terminal to positive terminal. So the voltage is increasing, plus 100. But here voltage is going downwards, positive terminal to negative terminal. The voltage is decreasing. So minus 40. Right? So now framed the voltage equation also. Now we'll simplify this resistance matrix. So 8 plus 4, 12. Then minus 4, 0. This minus 4. 4 plus 10 plus 10, 24. Then minus 10, 0, minus 10. 4 plus 10, 14. Now this is a simplified form of the resistance matrix. Then I1, I2, I3, the voltage 100, 0, minus 40. Now we framed the matrix. Now how will you find this I1, I2 and I3? The formula is available. Delta, delta 1, delta 2, delta 3. The three terms are available. So this is nothing but delta. The resistance matrix is the delta. In the resistance matrix, the first column is replaced by this voltage matrix, that is delta 1. If the second column is replaced by voltage matrix, this delta 2. The third column is replaced by voltage matrix, that is delta 3. Right? So this entire matrix is delta. Then by replacing the voltage, we have delta 1, delta 2 and delta 3. Delta 1 by delta will give the I1. Delta 2 to delta will give the I2. Delta 3 by delta will give the I3 value. Right? So now we need to find what is the delta value, del 1, del 2 and del 3. Thereby we can calculate the current. Now first consider the delta. Delta is nothing but the resistance matrix. Now we need to find the determinant. How will you find the determinant? First take 12. 12 means we need to multiply these two minus these two. So 24 into 14 minus 10 into minus 10. Right? Determinant is very easy. First we will consider this first element 12. While taking this first element, we need to eliminate these two. we need to multiply these two minus these two. So 24 into 14 minus 10 into minus 10. Then we'll take this element. Normally the second element will take minus. Already here minus is there, so it becomes plus. The second element normally will take negative. Why? We are multiplying these two terms. Normally it multiply by opposite, but while taking the negative we can multiply normally. So this minus 4 is plus 4. Now what we need to do? You need to multiply minus 4 into 14. Then minus these two terms. Already 0 is there, so automatically the term is 0. Then we take the third term. Third term is 0. So automatically the third term is 0. Right? So 12, 24 into 14 minus 10 into minus 10. Then plus 4 minus 4 into 14 minus these two terms. That's a determinant. I think your determinant you are able to know, you know this determinant very well. Right? So 12 into 24 into 14 is 336 minus 10 into minus 10 is plus 100, but already one minus is there, so minus 100 plus 4 into minus 4 into 14 is minus 56. Then 12 into 336 minus 100 is 236 minus 4 into minus 56 is minus 224. So 12 into 236 is 2832 minus 224. Subtracting these two, 2608. So this is the delta value. Now we calculated the delta value, 2608. Then how will you find the delta 1? Replace the first column with the voltage matrix. Voltage matrix is 100, 0, minus 40. Delta 1 is nothing but in the resistance matrix, the first column is replaced by the voltage matrix. Now we'll go for the simplification of this delta 1. So I take this 100 into 24 into 14, same thing, minus 10 into minus 10, same process. Already here minus is there, so it becomes plus. Second time normally we'll take negative, already negative is there, so it becomes plus. Then 0 into 14, 0 into 14 minus 0 into 14 become 0, minus 10 into minus 40. Right? The third term is 0, so automatically the third term becomes 0. So 100 into 24 into 14 is 336 minus this minus. This minus 10 into minus 10 become plus 10, that is 100, but already one negative is there, so minus 100 plus 4 into this is 0. So here 10 into 40 is 400, but the 3 negatives are there, so finally we'll get negative only, so minus 400. So 100 into 336 minus 100 is 236. 4 into minus 400 is minus 1600. So this 100 into 236 is 23,600 minus 1600. By subtracting these two, what we got? 22,000. The delta 1 value is 22,000. Now we'll go to the delta 1 value. Now we'll go to the delta 2. What is delta 2? We need to replace the second column with the voltage matrix. First column as it is, third column as it is. The second column is replaced by the voltage matrix. Here the first column is replaced. Now the second column is replaced. Now we'll go to the determinant. So 12 into 0 into 14, that is 0, minus 10 into minus 40. Right? 12 into 0 minus of minus 10 into minus 40. Then here while taking the second element we need to put negative, minus 100 into minus 4 into 14 minus 10 into 0, so automatically 0. The third term also 0. Right? Now we need to simplify this. So 12 into minus 10 into minus 40 is 400 plus 400, but our negative is there, so it becomes minus 400. 3 negatives are there, so finally we'll get negative only. Minus 100 into minus 4 into 14 is minus 56. Right. Now 12 into minus 400 is minus 4800. Here minus 100 into minus 56 is plus 5600. So this is negative, this is positive. So while adding, we'll get 800. The delta 2 value is 800. Now we'll go to delta 3. So the delta 3 is nothing but third column is replaced by the voltage matrix. First column, second column as it is, third column is replaced by voltage matrix. Now we'll go to the determinant. 12 into 24 into minus 40. 24 into minus 40. Minus 0 into minus 10. That is 0. Right? 12, we need to take 12 multiplied by 24 into minus 40 minus 0 into minus 10. This is the first term. Second term, while taking second term, this negative, already one negative is there, so it becomes positive. While taking second term, we need to multiply these two. Minus 4 into minus 40. Minus these two 0, so automatically 0. Take the third term, 100. Multiply these two. Minus 4 into minus 10. This side, 24 into 0, automatically 0. So 12 into 24 into minus 40 is minus 960. Plus 4 into minus 4 into minus 40 is 160. Become positive. Plus 100 into minus 4 into minus 10. Become plus 40. 4 into 10, 40. Both are negative, so become 40. So 12 into minus 960 is minus 11,520. Plus 4 into 160 is 640. 100 into 40 is 4,000. Now we need to add. Only this is negative, these two are positive. So the final value is minus 6,880. So delta 3 we are getting negative value. Delta 1, delta 1, delta 2 are we got positive. Delta 3 we got negative. Now we calculated delta 1, delta 2 and delta 3. From that we can able to find I1, I2 and I3. What is I1? Delta 1 by delta. 22,000 divided by 2,608. That is 8.44 ampere. The current flowing through the first loop I1 is 8.44 ampere. What is I2? Delta 2 divided by del. 8,000 divided by 2,608. That is 0.306 ampere. Second loop current is 0.306 ampere. Then I3, delta 3 by delta, minus 6,880 divided by 2,608, minus 2.64 ampere. So the loop 3 current is negative, minus. Why we are getting negative? The negative sign indicates the current is flowing in opposite direction. What be the direction we assumed is not correct. We assumed the clockwise direction. The negative symbol indicates the current is flowing in the anti-clockwise direction. That is not a matter. You can take any direction of current, but in the answer automatically you will get, if it is the direction what you choose is correct means positive. If the choose is not correct means you will get negative. From that we can easily identify whether the chosen direction is correct or not. We have one more question. Power absorbed by 8 ohm resistor. V into I. Power is V into I. The voltage nearby 8 ohm is 100. The current flowing through the 8 ohm is I1. So 100 into 8.44 is 844 watts. Power absorbed by 8 ohm resistor is 844 watts. The same problem solved by equation method. The link is available in the description box. The viewers can see that also. So in this problem we solve by matrix method. I1, I2, I3 is calculated and power absorbed also calculated. Thank you.